Assalamualaikum and a very good evening to all of you. Today we are going to present an experiment. The title is Synthesis of Thiocyanate Complexes. Before we going any further, let us introduce ourselves.
My name is Yasmin Nordiana binti Rasid. My metric number is 203894.
My name is Nur Atasha Fikri binti Azman and my metric number is 203180. Right, today we are going to talk about the objectives, and the second one we're going to talk about the introduction. The third one we're going to about the procedure, and next linkage of different synthesis complexes and the safety steps. So next. All right, the objective for the experiment is to describe the synthesis of different type of thiocyanate complexes. The second one is to distinguish the linkage isomerism exists in thiocyanate complexes. And the last one is to plan and consider the safety precaution in experiment involving thiocyanate.
Okay, for the introduction, thiocyanate or SCN- is a pseudo halide anion obtained by deprotonation of the thiol group of thiocyanic acid. It is a conjugate base of an isothiocyanate acid and a thiocyanic acid. Organic compounds containing the functional group of SCN are called thiocyanate. Okay, for the procedure, they have three types of complexes that will be synthesized. First is the synthesis of mercury thiocyanate. Second is the synthesis and characterization of the tetra-thiocyanate, mercury 2 corbate 2, and then synthesis of bis triphenyl phosphane nickel dithiocyanate complex, and then synthesis of copper triethanolamine thiocyanate, and the last one is the synthesis of cobalt ethylene diamine isothiocyanate complex. Okay, first for the synthesis of mercury thiocyanate, for the first step is the nitric acid was added into a flask. And then the nitric acid was react with 200 grams of mercury and form the mercury 2 nitrate. And then after a clear solution is observed, the solution was boiled. And then distilled water was added to dilute the mercury 2 nitrate solution. And then 200 grams of the potassium thiocyanate was dissolved in 500 ml of water. And then the potassium thiocyanate was added to the mercury nitrate solution, and the mercury thiocyanate is precipitated out from the reaction. After some time, two layers were formed, and the upper layers which the water was removed. And then the mercury thiocyanate was let to dry in air. So this is the chemical reactions for the complexes. The mercury metal will react with nitric acid and form mercury 2 nitrate, and then mercury 2 nitrate react with potassium thiocyanate to form mercury thiocyanate. So the picture shows the final product of the mercury thiocyanate. And then the next chemical reaction is when the nitric acid react with mercury. 4 mole of the nitric acid react with mercury will form 1 mole of the mercury 2 nitrate plus 2 mole of water plus 2 mole of nitrogen dioxide gas. Next is the synthesis and characterization of tetra-thiocyanate, mercury 2 cobalt 2. First is 3.5 gram of copper sulfate heptahydride and 3.8 gram of ammonium thiocyanate was dissolved in 10 ml distilled water. And then the solution was stirred constantly. And if the solution are not clear, the solution is filtered and boiled for not more than 20 minutes. After the solution is clear, 3.4 gram of mercury chloride was added in 40 ml of distilled water in separated beaker. The both solutions were mixed to form a clear solution, and then the solution was boiled for 15 to 20 minutes and cooled in ice bath. And then the precipitates were washed with diethyl ether or water. And then the crystal was collected in petri dish. And then the crystal was characterized by UV spectrophotometer. So the chemical reaction for this complex is the cobalt 2 plus 4 mole of thiocyanate to form the cobalt thiocyanate. And then mercury 2 plus the cobalt thiocyanate to form the mercury cobalt thiocyanate. And then the last is the copper sulfate heptahydride plus 4 mole of ammonium thiocyanate to produce tetra-thiocyanate, mercury 2 cobalt 2 plus the ammonium chloride, water, and mercury 2 chloride. As you can see in the picture, the final products of the complex is blue color. And then the synthesis of this triphenylphosphine nickel dithiocyanate complex. First, 2.82 grams of trimethylphosphine was weighed and added to a flask. And 30 ml of 99% anhydrous isopropyl alcohol was added to the flask. And then 1.2 grams of potassium thiocyanate was added to the anhydrous alcohol. And then the metal salt was added and stirred in the solution. And then 1.8 grams of nickel 2 chloride was added to the thiocyanate and alcohol mixture. And then what solution will be produced upon heating up the solution. And then the solution is filtered off and trimethylphosphate is added in the isopropanol. And then the solution was cooled for 5 minutes. And then the solution was filtered and washed with cold isopropanol and let it dry. And then the final product is brick red color precipitate was formed as shown in the picture. Then I will pass this presentation to Atasha.
Alright, for the next procedure is for the synthesis copper triethanol amine thiocyanate. Right, for the step one is 20 ml of distilled water dissolved in 3.2 grams copper sulfate. Stir and warm on hot plate until completely dissolved. And 30 ml distilled water was dissolved in triethanol amine and was stirred. And the third one is the solution of triethanol amine was added into the copper sulfate solution. The fourth one is 5 ml of distilled water was added to the potassium thiocyanate and was stirred until dissolved. And the fifth, the thiocyanate solution was added to the copper triethanol amine complex solution. The next one is the precipitate was filtered using vacuum filtration. And the last one is the precipitate was dried out at room temperature. All right, so this is the chemical equation, which is copper sulfate react with triethanol amine to produce copper triethanol amine. So the TEA is the short form for the triethanol amine. So the copper triethanol amine will react with potassium thiocyanate to produce copper 2 triethanol amine thiocyanate compound. And next, we know that the copper sulfate is in blue color and it will produce a green crystal, which is the copper 2 triethanol amine thiocyanate compound. Next. Alright, for the last procedure is the synthesis of a cobalt ethylene diamine isothiocyanate complex. Right, the first step is 1 gram of dichlorobis ethylene diamine cobalt 2 and 1 gram of potassium thiocyanate was weighed. And then 2 beakers each containing 1.5 ml of water was heated on hot plate. The third one, when the water was sufficiently hot, the weighed dichlorobis ethylene diamine cobalt 2 chloride and potassium thiocyanate was added into the beaker. The two solutions were mixed together to form green precipitate, which is intermediate. And the rate of stirring was when the rate of stirring was increased and the mixture gives reddish purple color, mixture was boiled for a few minutes. And the last one, the solution was poured into the cold glass state and left to precipitate. Next. This is the chemical equation. So the trans-dichloroidopis ethylene diamine cobalt 2 chloride react with trans-bis ethyl-diamine thiocyanate kappa N cobalt 2 thiocyanate, and the crystal after cooling will reproduce a red crystal in color as you can see in the picture. Next. So next we move on to the linkage of the synthesized complex. Right, the linkage isomerism occurs when ambidentate ligands that are capable of coordinating in more than one way. The only difference is what atoms the molecular ligands bind to the central ion. The ligands must have more than one donor atom but bind to ion in only one place. Right. For this experiment, we focus in thiocyanate ligand. So thiocyanate ligand is an ambidentate ligand which can be combined with the metal from the sulfur or from the nitrogen. So if the thiocyanate is combined at the sulfur, so it will call as thiocyanate kappa S. If the metal ion bind at the nitrogen, so it will produce a thiocyanate kappa N complex. Next. Okay. For the experiment, there is 5 compounds. So first of all is the mercury thiocyanate. So the mercury thiocyanate will bind to the S, to the sulfur. So it will produce a thiocyanate kappa S mercury complex. Next, the mercury cobalt tetrathiocyanate. So this complex, the cobalt metal is connected to be with the sulfur part of the ligand. So it is kappa S. Next, we move on to this triphenyl phosphine nickel thiocyanate complex, which is the nickel will bind to the nitrogen part of the ligand, so it will form a copper and thiocyanate ligand. So for the third video, which is the copper triethyl amine thiocyanate, the copper binds at the nitrogen part of the thiocyanate ligand, so it is kappa and thiocyanate complex. And lastly, which is the trans cobalt bis diethylamine isothiocyanate complex. So it will bind to the nitrogen part of the thiocyanate ligand. So it will be kappa and thiocyanate complex. Next. Alright, the last one is the precaution step. Next. Right, the safety steps in this experiment is throw waste of the solution in a waste bottle to dispose correctly, and carefully and slowly adding the mercury into the solution to avoid vigorous reaction occur. And experiment should be done in a fume hood because potassium thiocyanate because it is a toxic chemical. And then wash exposed skin after handling. And the last one is plastic container is put under the flask to avoid the mercury to nitrate from spilling. Next. All right, thank you. That's all from us. Do you have any questions?
Thank you.